All right, so with our boat questions, first thing we do is draw the river. There's actually a mistake on the key for this one. Okay, and it just has to do with where the direction is measured from. So we have this boat that can travel at 4 meters per second on still water, right? And it's heading directly north across the river. That means it's doing this. Well, it's trying to do this. What is it actually going to be doing? Yeah, it's going to be going off at an angle because the current, sorry, this is 4.0 meters per second, because the current is pushing it downstream at 1.2 meters per second. Or sorry, 2.1 meters per second. All right, so our resultant is here. All right, so they want to know what's the resultant velocity of the boat with respect to the shore. Well, this direction here, the one that they've got, east of north, that's not with respect to the shore, is it? Because it's not measured from the shore. This would be the angle I should be looking for if I'm looking for an angle that's with respect to the shore. All right. It's not that that angle is incorrect in terms of its number, it's just not where the question asked for it to be measured from. All right, so if I want to find this side, what do I have to do? Right, first do Pythagorean theorem, then I'll use tan to find the angle after that. All right, so Pythagorean theorem will mean, okay, that I'll take the two sides, 2.1 squared plus 4 squared. Okay, it gives me 4.52 meters per second. And then if I want to get this angle, I can either go tan with these two numbers the way they are and then go 90 minus, or I can just alter it so that I'm looking at it this way, which is the triangle I probably should use if I want to get this angle. So I'm going to make 4 the opposite side and 2.1 the adjacent side. Right, and that'll give me my 62 degrees from the shore, okay, or north of east, okay, in this case. All right, so that's for the first part. That's for A. Now, the second part, we've talked about this example already once before. How long will it take the boat to reach the opposite shore? Okay, well, the other piece of information we were given was that the river is 125 meters long, or wide, not long, wide. Okay. If I'm crossing it at 4 meters per second, can I figure out how long it takes me to get across? Okay, that whole time I'm going across, I'm also going down the river, all right? So I can use the time for both across and downstream. All right, so time equals d over v, so 125 meters divided by the speed at which I cross. That's key. Okay, I'm going across at 4, not 4.52. That is a very common mistake. All right, would it be 125 meters from one side to another if I followed the black line? Be quite a bit farther, right? Okay, I have to use the vectors that point in the same direction. This one and this one are both across the river, so they go together. Okay, so we're looking at 31.25 seconds as our time. Okay, now I can figure out how far downstream I would go. Same formula, just manipulated for D now. Okay, so that'll be 31.25 times 2.1, and I should end up, okay, sorry, we already got the 31, okay, but how far downstream will I end up? Well, 66 if I multiply that by 2.1. Okay, 66 meters. I cannot remember a unit exam where I did not have a boat question. Just like that one. Subtle enough? Okay. All right, try that one. It's not a boat question. I know it says there's a boat in it, but it's not a boat in a river. This is a vector addition, vector component addition question. Okay. All right, so let's start out with our first vector. We have 150 kilometers at 20 degrees east of north. All right, so my reference is north, right? And I'm going 20 degrees east of that. Okay, so here will be x, here will be y. This is 20 degrees, and it's 150 kilometers long. Okay, our second vector is 265 kilometers at 45 degrees south of east. So here's east as my reference. It's about 45 degrees. Here's x, here's y, and this is 265 kilometers. Okay, so the trick with this one is, did I draw this right? I drew it so that it got a little ways past my starting point in terms of y, but I'm not sure if that's where it's supposed to be just yet. Okay, so what I want to do is start calculating my x's and y's and then see if I drew the diagram correctly before I put on my resultant. Otherwise, it's just more for me to erase if I find out I've screwed it up. Everybody follow me there? So sometimes you get you draw the diagram and you look at it and you go, I'm not sure about this diagram. Well, the math isn't going to lie to you. Let's do the math and then see if the diagram is lying to us. Okay? Because somebody's lying here. Somebody. All right. So let's figure out the black triangle first. Okay, so black x is my opposite side, so it'll be the sine of 20 degrees times 150. Okay, black y will be the cos of 20 times 150. That's the one I'm most concerned with. All right, so that side's 51.3. And that'll be kilometers east. And then my y, okay, is 140.954. And that's going to be north. It's kilometers as well. Okay, same thing for our red triangle. Red x is our adjacent side, so red x will be 45, sine of 45 times 265. Okay, is 187. So I was right to draw it. Sorry, that's x. And it's also y. Why? Because it's a 45-degree triangle. Two sides are the same if it's 45 degrees. Okay, so I was right to draw it a little ways past where I started in terms of y. I might make it a little bit longer just to be a little bit more correct there. So 187.383. Okay, kilometers, and that'll be south. Okay, so I'm just going to adjust this line ever so slightly. I'm going to draw over my stuff here a little bit. All right, so now I've got that drawn. Now I can draw in my resultant, okay, which I know is going to go like this. Okay, and I'm going to draw the triangle outside just so I don't draw over other lines. My diagram's already enough of a mess. Y and x. Okay, so to get blue x, okay, I'm going to add both the x's together, so 51.3 and 187. All right, so it's 238.683. Kilometers east, and y. All right, so y will be 187.383 minus 140.954. All right, so 46.429. Kilometers south. All right, now that I've got those, I can calculate my overall displacement using Pythagorean Theorem. All right, so we're looking at 243.156. kilometers. We need that vector there. The way I drew it, x is the opposite side. So I'm going to go second tan of the 238.683 divided by 46.429. Okay, so 79 degrees. All right, now I need to, so that's my overall displacement will be, we have two significant figures. So this answer is wrong. Okay, it should be 2.4 times 10 to the 2 kilometers at 79 degrees, and that'll be east of south. Or you could have the 11 degrees south of east, whichever way you drew the triangle is fine. And then I've got to calculate the overall velocity because they did ask if it takes 12 hours, what was the overall velocity? So I just take my 243 and I divide it by 12 hours and I'll get my 20.3. Okay. Questions on that one? Right, we've done a number like that. There was one on your quiz just like that yesterday. Okay. All right, let me give you the rest of the class to work on your map thing. Okay, so if you want to get together with your group and get a few more map things done, okay, go ahead and do that.